Okay, so I'm going to say, I'll do this quickly for you guys. I want to be fast today. So I'm going to actually see the derivative. So I'm going to say f of x is equal to cos of x. F of x is also then equal to sine of pi over 2 minus x. Okay, we're actually going to do this, we're going to take the derivative of this one using chain rule. What is the derivative of sine x, please? Yes. So f prime of x is equal to cos using chain rule. What's going to happen after that? Derivative of the inside. What's the derivative of pi by 2? Sorry? No.
Zero.
The pi is actually, yeah, it's going to be 0 because pi is a number, right? 3.14. So what's the derivative of pi over 2 minus x going to be? Negative 1. Okay, how do we expand this? I don't like that pi over 2. How do we deal with this cos of pi over 2 minus x? I don't know what the derivative of cos of pi over 2 minus x is equal to. All right, I cannot stress this enough. These derivatives you gotta know. Those things you gotta know. So this is equal to negative sine x.
Why did it go back to sine? Cos of pi over 2 minus x equals sine.
Yeah. There you go. So for Michael, who thought the derivative of cos of sine x, he was very close. Okay, it's actually the negative sine of x. Now that's wild. No one else is amazed by that. Okay, I'm amazed. I know we did a lot of math, so you guys are all down. You say yes, I hate proofs. Okay, that's fine. Okay, but look what just happened. That's amazing. The derivative of sine is equal to cos. That's wild. A question or an answer?
Why did you have to change sine to cos like that?
Okay, the reason I had to change, because, good question. The reason I had to change this to sine was that I can take the derivative of sine, right? So I didn't actually do that. Now, the reason I changed it back, well, just because it's easier in terms of x. That's why at the end. Okay, right? So you could have expanded this out and done, your cos formula, right? So yes, and that would work out the same way, but that's just a short form to go right from here to here. Then there's no pi's in your answer and all that stuff. Because when you take the derivative of something, if you have to throw a pi over 2 every single time you take a derivative, now, I'm going to apologize, I haven't given this enough glamour, okay? This is miraculous what we've just shown. Like, think about what just happened, okay? If you go back to the graphs here, we've just shown that the slope of this, well, take a look at the slope of this. Well, that's going to be 1. Hey, look at that, it is 1. And the slope's going to get less. Well, all of a sudden, hey, look at that, the slope's 0. Hey, look at that, the slope's negative. Hey, look at that, it's negative. Oh, wow, look at that, it's negative 1. Oh, back to 0. Right? That's miraculous what's just actually happened there, okay? But that's actually the way it works. Right?
What is sine? Or it's like what part of it?
I'm going to pause. Okay. Okay, and thus 1 equals 2.
Do we have to find the derivative of tan?
Yes, you will have to find the derivative of tan. You can do that very easily. Do you want to do the derivative of tan next? I think that's my next example.
Sure. So enthusiastic. What about like sine inverse and cosine?
Oh, you have to do all those ones too. Here we go, example 3. I want you guys to find, we'll do this as a class. I'm going to get no help here though. Find the derivative of tan x. Okay, the derivative of tan x is very easy. Okay? I'm going to give you the first hint and you guys are going to take it from there. How can I represent tan in terms of something that I can already know how to do?
Sine theta over
So sine theta or cos theta. Sine x over cos x, I'm gonna call it.
That's okay.
Okay, what law would you use to take the derivative of that? Quotient. Okay, so use quotient right now to do that. If you say to yourself, I hate a quotient rule, we're glad that unit is over. Too bad, because it's coming back again. Okay.
Use sine.
Okay, so let's do this as a class. U equals what? Sine x.
Yeah.
U prime is equal to.
Cos x.
Good. V is equal to. Yeah. V prime is equal to.
Oh, negative.
I'm going to pause in the video and you guys are going to take the next 60 seconds of your lives to finish this off. Okay?
This is math.
Courtney, you're up. F prime of x equal to what? Okay, so u of x is going to be no. V of x, it's going to be the derivative of the first one first. Okay, so it's going to be cos x times cos x minus u times v prime, so sine x negative sine x all over my denominator square, which is cos squared x. Okay, please everyone close their eyes and put your heads on your desk for a minute because this is extremely important. Robert, you too. Please raise your hand if you don't know what just happened on the right-hand board. The proof, forget about the proof. What just happened on the right-hand board, raise your hand if you do not understand. Okay, heads up, please. Okay, so what we just did was we just used quotient law. Okay, so we just used quotient law here, right? U of x times v prime divided by v of x times v prime. Okay, how does this neaten up? John, go.
Cos squared x plus sine squared x over cos squared x.
Okay, now this is where the magic has to come in of trigonometry. If you tell me this is equal to cos squared x plus sine squared x over cos squared x, shame on you. Okay, what is cos squared x plus sine squared x equal? Thank you. So f prime of x equals 1 over cos squared x. Some textbooks will write this as secant squared x as well. Okay, but 1 over cos squared x first. Now, what you are learning today is that all the same derivative rules we have learned before work for any type of function. Okay, so we're going to get to, we did a chain, we did a quotient. Okay, so you can use anything you want. I'm going to pick a big messy derivative next to do right now. Now, don't guys, just wait. Don't be intimidated. You guys already dominated the derivative chapter here. Like, the worst thing I want to do is like cos squared x plus 5. I didn't say the vector unit. I said you dominated the derivative part. Okay, so pause here.